Alrighty, g'day, hi, hello. Welcome to this session, Database Reliability Engineer, the new DBA. I'm Hamish Watson. I've been working in IT for just over 8,500 days, so a wee bit of time. I love DevOps. If you've heard me speak before, it's generally will be on the subject of DevOps. And bringing DevOps to databases and the masses, i.e. people, is a personal passion of mine and has been for some time. Understanding data and helping people embrace both, Azure or, say, the cloud is one of my company's drivers. I'm based here in Christchurch, New Zealand. But I work with companies all over the world because thanks to the current situation we're in, remote working is now a thing. So it doesn't matter where you live in the world, as long as you can help people, make stuff go. And the core of who I am, I'm a technologist who basically understands business value. Often we have technical people who are very good at their jobs, but are not good at working with management or customers, or are not very good at understanding where they fit in the machine, as it were. Whereas I'm driven by business value, because if people aren't paying us, we can't do stuff. And being able to translate that into what people are putting into, say, their databases, or any app for that matter, is one of my key strengths. If you follow me on Twitter, you'll see the hashtag #MakeStuffGo. It's, both a personal driver of mine and personal statement, as well as just how I work in industry. I'm Microsoft Data Platform MVP, as well as a friend of Redgate and VMware expert. Do a lot of community stuff, which is awesome, and it's really great to be part of SQL Bits, a conference that I had hoped to go to by now. It was on my plan for 2021, but never mind, I'm doing it virtually. Alrighty, so a number of years ago, in fact, goodness, at least 4 years ago, I bought a book, Database Reliability Engineering, written by Laine Campbell and Charity Majors. And basically, it changed the way I looked at some of the things I did. At the time, I was more a DBA than, say, a database reliability engineer. I was doing DevOps stuff with data, but it really changed my perspective. And basically, when we think about it, data is an organization's most important asset. And I understood that, right? Because I was kind of this gatekeeper of the data, ensured that when it came to production, that, things were okay. But the problem is the critical nature of this often brings fear and reservation when we're working with data. And often organization will restrict itself from innovation to prevent risk to our data. So basically, what I saw as the database reliability engineer once reading this book was they allow the organization to innovate with their data instead of being stifled by gatekeepers like myself, and also risk-averse policies. And so one way we can address this is through automation. And a database reliability engineer will actually wear multiple hats, including one of a site reliability engineer. And basically, when it boils down to it, reliability engineering is about automating yourself out of any manual work if possible. Right, so I said the term site reliability engineer, and some of you may have already heard of this. Basically, Google kind of came up with the concept of site reliability engineering. They also came up with a free ebook around it, which you can go and read. And basically, the SRE team is responsible for the availability, latency, performance, efficiency, change management, monitoring, emergency response, and also capacity planning. And that's why I say we often have multiple hats on. Yeah, it's taking some engineering concepts that have been out there. It's about embracing software development lifecycle and incorporating it into our current role. So you might be a DBA, and by the way, I was DBA for over 15 odd years. This is not a beat up session on DBAs at all. What it is about is the role of the DBA basically evolving. Right. So we once worked on SQL Server, whereas now we work on a data platform. And even, Microsoft has evolved the name of the SQL Server platform to the data platform for many good reasons. We also need to embrace the cloud more. These days, data exists both on premises and in the cloud. If I can look at scenarios, we might have some data that's being retrieved across a big data cluster, say running on Kubernetes clusters. It's being consumed by some open source services that are interfacing with, cognitive intelligent applications hosted up, in a cloud service like Azure somewhere. And then basically we've got machine learning models that are going to, take all this great data and turn it into, say, predictive analytics, i.e. making information out of it. And so our usage of data has changed dramatically in the past 5 to 10 years. And with it, we need to look at different ways of dealing with these new scenarios. So we need to embrace automation. We need to learn some DevOps principles. And we do need to evolve from administrators to engineers. And so, our administrative guardians of that data, DBAs, like myself, we also need to evolve with all the changes that have occurred both in the platform and with technology as a whole. All right. So I love this picture because it basically depicts what happens in industry. We have a development team, they've written some code, database code, and just lob it over the wall and give it to the poor DBA. This gets me out of bed each day. I want to stop this scenario and I want to break down that wall. I definitely do not like code grenades. And basically a code grenade is where the first time I ever see the code is basically when I am told to put it into production. And that's probably at 3 a.m. and I've got it, 4 p.m. the day before. So I don't like this scenario at all. Anyway, database reliability engineering. Historically, to protect the most precious resource we have quite strict separation of duties between software teams or software applications and the DBA. But the problem is that strict separation of duties is not just burdensome, it restricts innovation and velocity because we have to, stop, check before we move forward. As DBA, we had rigorous backup and recovery processes, which were regularly tested because I'm not paid by the backups I do. I'm generally paid by the recoveries that are successful. Anyone can do a backup, but if you can't recover, you're going to be looking for another job pretty soon. We had quite well-regulated security procedures, which were also regularly audited because, again, we are the guardians of the data. And we had quite expensive database software, which had strong durability guarantees. And what that meant was that that every transaction that went through our database, we knew that it was written to disk. We knew that it was there if we needed to read off it. But all of this cost quite a lot of money. We had underlying expensive storage because, again, we needed that durability. We needed to know that every single transaction, every change within our database was on disk. We had redundancy of all the components because if something went boom, then we could recover. Oh, not just recover, we'd actually still stay running, disk drive, whatever fails, we've got another, 2 or 3 that can take over, host bus adapter and our physical hardware. If one of them goes and, one of the paths to the disk storage is gone, we know that we've got another 1 or 2. So that kind of thing, we spent a lot of money ensuring the path to the storage and back again was as redundant as possible. And we had extensive controls on changes and administrative tasks because, again, we did not want people just willy-nilly changing our most precious resource. And so we needed to ensure that every change was extensively looked at, and any change to anything within our data ecosystem was, audited and had those controls around it to protect it. So what's New World look like? Well, we're going to allow for the responsibility of the data to be shared by cross-functional teams. And so, what this means is we actually need to discuss ways and implement safety nets, and again, reduce that separation of duties, because just like that picture where we're throwing things across from one team to another, that takes time. And when it takes time, that means that, it can become a bottleneck. We're going to standardize and automate our backup and recovery processes. And excuse me, we're going to standardize the security policies. So this means that the DBA is not going away at all. In fact, we need better DBAs more than ever, because we're going to actually standardize all these things and provide them to our teams to use. So we're actually going away from administrator to, enabler. All policies will be via automated provisioning and deployment. So again, we're going to work with a number of teams, because I don't know about you, but I don't know how to automate policies within, say, Azure AD, but someone within the company will, or, we're going to get out of our silo and actually start interacting with a wider range of skills within the company. And we're actually going to move away, gone are the days of the truly monolithic SQL database application. If I look at startups, when I work with them, they're leveraging distributed data stores spread across the cloud to solve their data problems. And, the business needs faster velocity to deliver that value. And, think about the data requirements. They're skyrocketing in complexity. And so today's data problems require a really new approach to planning, managing, and scaling our data stores. And so basically, the database reliability engineer is a modern data administrator that enables the company to innovate with their data by using, we might be using less expensive data stores, but we need to make things safe and accessible. And so, again, you know, we're going to use automation. We're going to use tooling to automate manual tasks, because manual tasks are what kills us. Manual tasks and handovers. And so I said it before, reliability engineering is about being an enabler. It allows engineers to move fast without breaking things. Alrighty. Part of this is we want to create a platform that enables self-service. And so, you know, as I said before, we need talented DBAs. And so one of the things we have to do is we need to know what's running, what's working within our data ecosystem. And so part of this is having appropriate metrics, gathering information about the performance and health of the data stores and data technologies that we're using. We're going to be building backup and recovery utilities that can be deployed for those data stores. And we're going to be defining the architecture and configuration for the data stores that are approved for operations, right? So, you know, a group of us, both infrastructure as well as, you know, DBAs, database reliability engineers, we're going to provide this framework for our platform that enables teams to deploy whatever they need. We're going to work with security, because we need to define standards for the deployments. You know, we want to ensure that things are done in a safe manner. And again, we're going to have deployment methods and a whole heap of scripts that means that, you know, the change sets that we're applying are going to be done in a safe and efficient manner. Basically, most of this session is around automation, because again, we want to enable our software engineers to move fast without the concern of losing data, and where we can take out those manual tasks like checking it. You know, we might write some integration tests. We're definitely going to write unit tests for, you know, any stored procedure that we're putting out there. You know, again, we want to innovate. We want to innovate instead of being stifled by those old manual gatekeeping and risk-averse policies. So one way I like to think of it is, you know, reliability engineering empowers others and guides them, not function as the old gatekeeper. And maybe it's as simple as saying database reliability engineers say yes, whereas in the past a DBA would have said no. Toil. I've talked a lot about manual tasks, and Google came up with this great definition around toil. You know, it's manual, it's repetitive, it's automatable. So not everything, you can't automate just everything, but there are some things that we can automate. And so what we want to do is, you know, we want to eliminate this by automation, because if something's repetitive, non-creative and non-challenging, get rid of it, you know, in terms of doing it manually. We want to automate that. You know, if we look at, you know, the role of the DBA, DBAs were asked to review and apply database changes, not just, you know, production, but other environments, right? Might be a staging test, whatever. And these modifications, you know, might be to tables, indexes, whatever. But, you know, a lot of times this was done manually. But everyone felt assured that DBA is applying these changes and monitoring the impact of the changes in real time. Now, as a DBA, I remember that often I didn't get a chance to do some of those things. Monitoring the impact, sometimes, there was so many manual tasks in my personal backlog that I couldn't. And so I was slowing things down, not on purpose, but just by the very nature. And so, if we look at modern businesses that are wanting to be more agile, the rate of change can be quite high. And so these changes are quite impactful. And so, I've seen DBAs who have not got on board with automation, and, they spend their whole time running repetitive tasks over and over, and eventually becoming, overworked, losing interest and basically quitting. And we don't want that. All right, so here's some tools. We've got to do workflow management. We actually need to know what is in our backlog, right? What am I going to work on? What issues are coming along? We need source control. I'm going to talk about source control quite a bit in this session as well. And we need an integrated development environment, right? So we've got to write code somewhere, and we're going to automate the build of our software and code. We're going to do some automated testing, please. And we're going to do an automated release. Gone are the days of F5 at 3 in the morning watching a script. Now you probably say, well, wait a second, Hamish, this is great technology stack for developers, and it looks pretty old because it's Team Foundation server, it's not Azure DevOps server. Yeah, okay. So I've been using this slide for a wee while. And in fact, the technology stack may have changed a little bit. And in fact, you might be using these to do all of the things that I've just talked about. Or in fact, you might be with the cool kids and doing a whole heap of different things. You know what? I don't care. I don't care at all. What I do care is that you are using some tooling to look at ways that you can automate, you can monitor, you can release, and you can do all of these things that eliminate that manual toil that you're doing. So look, whatever tooling is appropriate for you. The number of times where I've gone in and I'm working on a client's SQL server and it has a nice little name, and they treat it with care, they nurture it. And so you may have heard the term, treat it like cattle rather than pets. The metaphor of cattle versus pets is often used, to differentiate or show the difference between a special snowflake and a commodity service component. A pet server is one that we feed, we care for, and we nurture back to health when it's sick. It also probably has a name. Whereas cattle servers, they've got numbers, not names. We don't spend time customizing servers, much less logging on to the individual hosts. When they show signs of sickness, we cull them from the herd. Now, if we are seeing unusual amounts of sickness, we might actually keep one or two around for forensics. But, we're going to strive for standardization, automation, and resilience. And so, critical to this is the idea that the components of database clusters are not sacred. We should be able to lose any component and efficiently replace it without worry. And this, again, goes on it's changing the persistence model for us. Back in the day, I used to make sure that SQL Server.exe was up and running. And, my SQL Server instance running was the most precious thing. And, yep, things are on disk. Whereas these days, we may be running SQL Server in a container and a number of containers within, say, a pod running on a cluster. And so if our SQL Server instance goes within, seconds, we're on another SQL Server instance, and our data that's where the persistence is. We've sort of changed the model. And so it's, again, that change in thinking about our database technology should be resilient. It should not be this massive monolith, expensive bit of software. Reliability engineering is around collaboration. And this is where it sort of aligns nicely with DevOps, hence why I'm interested in it. Your infrastructure configuration, basically everything that we do is all part of software. And so I do recommend that, you know, if you don't understand what software development lifecycle is all about, you know, go and look at it, because you're going to be part of it. We're not just off to the side anymore. And you need to embrace, you know, being able to code, test, integrate, you know, with other code, i.e. application code, database code are going to come in at some point. We need to build that together. We need to test again and deploy. And in fact, I like to have it a test after this, you know, that smoke testing after a deploy, which will hopefully be automated. So automation and testing are quite key to what we want to do and where we want to go. I don't mean this kind of testing. This kind of testing is bad because the developer on the left has said, I coded a 6. And the tester on the right says that's not a 6, it's a 9. But the problem is the client actually wanted a G. And so we need to consider how we align with user requirements. What does the client or what does the end user actually want? They don't care about, you know, rows, columns, ones and zeros. They care about the value that our software is delivering for them. Because again, we want them to pay us and to pay us well. We're not going to do that if we deliver a 6 or a 9 when they actually wanted a G. So I talked about automation, testing, collaboration, you know, and again, we had DBAs who were sort of off to the side, you know, delivering, watching, gatekeeping. But we need to eliminate the barriers across all teams. And the thing is, it's been proven within application software and more so within database being part of this. Whereas if we remove those silos, we can improve the reliability, that's a good thing, performance and velocity of our deployments and releases. And so we will find ourselves embedded directly in software engineering team, working in the same code base, examining how the code is interacting with our data stores, and then modifying the code for performance, functionality, and reliability. So again, you know, you're going to be part of the team. One of the things I used to do, oh goodness, this was back in 2011, was I took my DBAs, because I was manager, to team stand-ups, application team stand-ups and planning sessions, so that we knew what was coming in the pipeline, not at 4 p.m. on a Friday for delivery at 3 a.m. on a Saturday. Right, service level objectives. What are the expectations of our database? You know, what we need to define the service level objective. And often this is defined by the business. They say, well, we want this. And so what we need to do is find a way to measure whether or not we meet that service level objective. And honestly, it's hard. You've got to go and find a way to measure this. Well, we can use things like service level indicators. What's the latency of our system? How available is it? What's the expectation? What's the baseline? Are we there? What can we do differently? The throughput, how quickly does something come in and we get it back out to an application? And of course, durability. How durable are things? Because we want durability, even if we are using commodity software and technology. We need monitoring most of all. We need to know what's going on in our database or data store. And the number of times where I've worked with clients and say, right, let's have a look at your monitoring that you're doing with your database server, and I just get this blank look. They might be, you know, monitoring the VM to know that it's up, but we need to get right down deep because we want to measure these service level indicators. So you probably think, cool, you've talked for, 30 odd minutes, Hamish. How do I start? Well, here's the deal. The one takeaway. You need to stop using this as your source of truth, and you need to start getting your database into source control and your database code. Your database schema into source control, and more importantly, your database code into source control so that it's auditable, so that we can go back to a prior version, not just some file on a laptop somewhere on someone, someone's home now. Because now that we're distributed, we need to be using things like source control for all the things so that we can integrate our code. But more importantly, if my laptop dies, that doesn't mean that, that stored procedure that we have running in production, that's the only copy gone. Alrighty, here's the path. We want to remove the silos. We like to think, hey, we're all a team, but in fact, we find that we're a team of individuals. We're not aligning together. And so we definitely need to do that. Back in the day, so this was 2012, when I first really got DevOps humming at the software company I worked at the time, we spent more of our time arguing what DevOps was. And so I came up with a definition so that we could work towards this, and this was our benchmark. Any piece of software we used, we measured it against whether it would make stuff go. And this definition I came up with has been great in terms of helping clients understand what they need to do. We've got tools, we've got the world's best tools, but if we have a manual process, that doesn't allow us to automate things, it's going to be disjointed. It's not going to work. And the key thing is we're going to deploy business value to our clients, not software. They don't care about the ones and zeros. They care about value. So ways you can start your DevOps journey, or rather ways you can start your database reliability engineering journey. Source control, it's key. You've got to embrace it. There are a lot of sessions out there, both free and at conferences like SQL Bits that will show you how to use source control. I used to say to DBAs, if you can write in T-SQL, you can do the 6 commands, the 6 Git commands that you'll ever need to use. Unit testing, you need to do it. Infrastructure as code, rather than just clicking next and randomly setting up both servers and software, we actually want to define it in code so that it's scalable. Continuous integration, being able to bring together code into source control, build it, test it, and create a standardized artifact package that we can deploy out multiple times, ergo continuous delivery. I don't call it continuous deployment because that's too far up, right? You got to start simple. Continuous delivery, we will deploy through multiple environments that are built from source control, thereby they're nice and standard. But at one point, a human or an automated piece of code, like a gateway, will decide when we go to production. That's the difference between continuous delivery. We still have a gatekeeper within our process. Continuous deployment is where I cut code, goes to source control, gets built, gets tested, deploys through different environments, and ends up in production. Boom, done. You can get there eventually. But yeah, continuous monitoring and testing. We definitely want to embrace monitoring. We've got to know what's going on, and continuous testing throughout, unit testing on my laptop, build testing at build time, integration testing when we're bringing a whole heap of environments together, UAT, we might leave the humans near it, and of course stress testing. And if we can automate, majority of those, then so much the better. Righty, one contentious thing I always hear from DBAs is, I can't unit test, I don't know how to write in C#. The best thing is T-SQL-T. It's a great framework written by a couple of people that are more passionate about the safety of your database than you are. T-SQL-T is free. T-SQL-T has the world's hardest URL. It's tsqlt.org. The best part of T-SQL-T is it's written in T-SQL. So if you're a DBA, you might want to learn how to write T-SQL, and then you'll be able to write unit tests. I've talked about infrastructure as code. You've got to stop clicking next. We need to treat our SQL Server install configuration, in fact, all data stores that we're dealing with, as code. Containers, the cloud, desired state configuration, which is PowerShell module, Terraform, Ansible. These can't be foreign terms to you because these are the new normal. They're what we're doing day to day in terms of building, configuring, managing, and monitoring our data technologies. Infrastructure as code solves inertia. We want more of this, right? So defining what we're doing in code, because this is scalable, and we want less of this because this is human. Now, this is installing iOS or some app or something, and you're going to say to me, wait a second, Hamish, we do database stuff, not SAP stuff. And this is running SQL Server in a container on a cluster, Kubernetes cluster somewhere. So we can actually embrace, what application developers have been doing for a long time and apply it to a database. And in fact, some days I write in this more than I do any form of database code. This is Terraform, which is a great piece of software, which allows us to configure and install standardized installations of this is Azure SQL. Terraform's great. It's not just about the cloud. You can do it on premises as well, and it ties in nicely with a whole heap of other technologies. We've got to start looking at different ways of interacting with our data. And so I recommend that DBAs or data professionals start looking at a number of different languages, because here, with machine learning uses Python and SQL Server. We will use former T-SQL. We're even going to use JSON, because this is handling how we do the monitoring of our systems, and databases and database technologies are in there. The key thing about all of these different languages is that data is the common theme here. Now, if you haven't looked at DBA tools, please do. It is a fantastic set of frameworks, and more importantly, it's free. It's written in PowerShell, and don't be scared if you're not good on PowerShell. First of all, it has a whole heap of different modules that you can use, but it's got great write-ups and great examples. So I used one of their modules. I used to do syncing of logins and jobs across availability groups. And I had, I think, 20 lines of T-SQL and 4 lines of PowerShell. It worked most of the time, but it was pretty ugly. It was literally 1 line of DBA tools. Please go have a look. Alrighty. We need operational visibility. We need to know what's going on. And, you know, DBAs use DMVs, whereas the database reliability engineers are going to use operational visibility so that we can actually see what's going on in our systems and be able to react. So, and, you know, I live in the cloud, I admit it. The majority of what I do these days is cloud-based, as people see that as a more efficient and cost-effective way of dealing with their data. And so, you know, again, I'm using monitoring tools. You know, I showed on-premises one from Redgate. Here's one that, you know, we can use up in Azure. The key thing here is getting those metrics, understanding what is going on in our system. And so you can do this on premises, it's not just about the cloud. There is a number of tools that will enable us to get, you know, get those service level indicators, because we can tie what's going on with our system to where we want to be with facts and figures, you know. Some might say data. Alrighty, let's bring it all together. Landscape has shifted in the past few years. We're not just administrating databases, we're actually engineering a data platform. You know, we are dealing with different data stores and data technologies that is taking a wide range of data from multiple different sources. It's being transformed in many, many different ways for many, many different use cases. So we're not just administrating that, you know, monolithic database. We're actually having a whole data platform that we're involved in. We need to ensure, though, reliability, because chaos and risk are not great for data. You know, I used to say when it came to deployments, deploying databases is far, far more difficult because, you know, for a web server, if we get it wrong, it's just a bunch of DLLs, delete them, put in a new DLL. Because you can't really do that easily with data. You know, we care about the state of the data, but, you know, how we got there as well. And that level of persistence of data, it's quite important. It's not just a bunch of DLLs. We talked about virtualization. I've talked about infrastructure as code, containers. You know, we now have serverless computing, which is pretty cool, and can be quite cost effective if you do it right. We have distributed systems that are based in the cloud, and this is now commonplace. You know, I think of years ago, you know, virtualization was a new thing for me, you know, back, you know, 15 odd years ago, whatever. And then, you know, we could run database technologies reliably on virtualization. Well, we're moving forward, right? Now we're looking at containers. You know, majority of what people can do can easily spin up a container. Or, again, like I say, serverless computing if you're in the cloud. So we need to embrace aspects of these, and we need to bring our databases into these paradigms. Culturally, we need to break down barriers. We're all marching towards that same goal, and that will be an organisational goal of what value we are delivering to our end users, not just the, you know, rows, columns, indexes. We need to treat everything as code so that we can store it, we can audit it, and more importantly, we can scale it. And we want to have automation of nearly all the things. You know, you can't automate absolutely everything. But again, if it's trivial, if it's repeatable, non-challenging, non-creative, automate it, get rid of it. We need to know what's going on. You know, we need monitoring and operational visibility. And these are key for data-driven decisions as well as the technologists. And yeah, that is my session. I'd like to thank you very much. I'm sticking around for 5 minutes. I did have a feedback form, which I am going to quickly find, because that was supposed to be here somewhere. But yeah, those are my details. And yeah, if you have any questions, please do put them into the chat, what have you, and we can I can answer them. I'm just finding where the slide was with the.
So we've got one question online, Hamish.
Yeah.
Is there any suggestions for good unit testing?
Yeah, there is. And in fact, let me just put up the slide. I put it in the PDF. So, unit testing. Could you repeat the question again? Sorry.
Any suggestions for good unit testing other than T-SQL test?
Okay, yeah, cool. And there, I'm hoping that you can see the feedback. Please be kind.
Yeah.
Yeah, absolutely. I mean, back in 2017, at what used to be Past Summit, I did a whole session on free unit testing, and so we used SQL Server data tools, right, which is built into Visual Studio. So it's technically free. You don't have to write in C#. It allows you can write in T-SQL within Visual Studio. I know. But it enabled us to actually embrace some of that unit testing. And in fact, one of the cool things about it was it enabled us to get our database into source control. So that's one reason why I embraced it. But then when they brought in unit testing within SSDT, it enabled application developers to start writing those unit tests. There are a number of paid unit testing frameworks that you might want to look at. I mean, Redgate do what they call SQL Test, which is a unit testing framework. Funnily enough, SQL Test in SQL Toolbelt is based on top of T-SQL-T, which is kind of cool, yeah, I mean, it depends also what technology you're working with, because some of the testing that we might do, we might use things like Cucumber, Gherkin. Those are behavior-driven development testing tools, whereupon we write a whole range of tests that we want to run, when we cut the code, but behavior-driven comes from the requirement of the users. So, yeah, there's a whole number of testing frameworks you can use. The reason why I choose T-SQL-T is generally, one, it's free, and two, it allows people to write in T-SQL. But honestly, you could use any number of unit tests. I mean, there's ones within the Microsoft stack as well as open source ones. Yeah.
Cool, thank you.
Sorry.
Does DBA Tools offer any testing frameworks?
You can you can write stuff using DBA Tools. Yes. That's a good point. Sorry about that, DBA Tools. Sorry. DBA Tools is fantastic, by the way. Written by the community, for the community. Can't get much better than that, right? Yeah.